So 6.5 WSPM, this is just pick which method you want to use. What method do you think is easiest to do this? Graphing, substitution, or linear combinations?
Substitution.
Elimination method. The linear combinations method is probably the fastest. You could do substitution if you want. It'll just probably take a little longer. And also you could even graph it if you wanted to, but it would take a little longer. So if you wanted to eliminate, you either need to decide to cancel out x's or y's. What do you prefer, canceling out x's or y's?
Y's.
Okay, I'm just going to go, the more people said x's. I would probably pick y's because one's already positive, one's negative. But let's go with x's, all right? Let's go with x's. So in order for the x's to cancel, you're going to have to make that top 5x become 15x. So you're going to multiply by 3. That way you'll get 15x plus 9y equals 30, 18, 48. And the bottom equation, you're probably going to have to multiply, or you're going to have to multiply everything by what? If you want the x's to cancel by negative 5, that would be a negative 15x. It'll be a positive 25y, and it'll be a positive 20. And now it's ready to combine, cancel, and solve. So we're going to combine the x's, eliminate. We did that on purpose. We chose to cancel out those x's. And 9 plus 25, that's 34. And we're talking about y's. And it equals 48 plus 20 is 68. You divide both sides by 34. Divide by 34. We end up with y equals 2. We have one answer, we need the other. We're just going to plug it back into any equation we want. I'm going to go with the top equation. Top equation reads 5x plus 3y. But notice I'm going to put parentheses so I could plug in that 2. Instead of the y, I plug in the 2. And we still have the equals 16. Doing the math here, I have 5x plus 6 equals 16. So I'm going to have to subtract 6 on both sides. New equation is 5x equals 10, which means that when you divide by 5 and you divide by 5, your x value is 2. So your answer to number 1 is the coordinate 2, 2. How could you double check? All you got to do is plug it into each equation and see that it actually gives you 16 up here and negative 4 down here, which it does. So on number 2, do you think it's a good idea to do substitution?
No.
No. How about graphing? No. You could do substitution if you want. You could do graphing if you want. But the best method is linear combinations, a.k.a. elimination method. Why? Because the x's are already on top of the x's, y's on top of y's, equal on top of equal. All you need to do is make either the x's or the y's to cancel. And it's already ready to cancel out what? The y's, right? So you don't even have to do anything. This is already ready to combine. You know what? I know some people get thrown off with the plus sign. I'm just going to erase it. I'm just going to combine 3x and 2x, and I'm going to get a total of 5x's. And then I'm going to combine the negative 5y and the positive 5y, and that's where it eliminates. The equal signs are going to come down, and 7 plus 13 is 20. All we have to do now is divide by 5, and we're going to have x equals 4. You have one answer. You need the other answer. What do? Plug it in. Which one would you like to plug it into, top or bottom? Bottom? Bottom has no negatives, so might as well go with the bottom. Notice that the bottom equation says 2x plus 5y equals 13. Instead of this x, I want to put parentheses and plug in the 4 right in there. So 2x, but I'm going to plug in the 4 in place of x, plus 5y equals 13. So 2 times 4 is 8. 8 plus 5y equals 13. And of course, I'm going to solve this thing by getting rid of the 8, subtracting 8 right there, subtracting 8 over here. We're going to have a new equation that reads 5y equals 5. My final step right there would be to divide by 5 and divide by 5, and y equals 1. So x equals 4, y equals 1. I'm on your answer sheet Friday, put 4, 1. 4 is your x value, and 1 is your y value. If you wanted to double check it, which a lot of people turn in their tests early, I wouldn't turn it in unless I take this 4 and plug it in right there, take the 1, plug it in right there. I would use a calculator and type in 3 parenthesis 4 close parenthesis minus 5 parenthesis 1 close parenthesis, hit the equal sign, see if it does give you 7. It's really easy to check, especially if you have a calculator. You could just plug it all into the calculator, hit equal, and it should give you 7. You could do 2 parentheses, and in the parentheses plug in 4, plus 5 parentheses, in the parentheses plug in 1, equals, hit the equal sign on the calculator, see if it gives you 13. If it gives you both 7 and 13, you've double checked it, you're absolutely positive that the answer is 4, 1. Let's try another one. Number 3. Since elimination method went so well on number 2, we should probably do elimination right here also, right? Wrong. You don't want to do elimination here. Why not? It's not set up to do it. Notice that you don't have x's on top of x's. The equal sign, what? That equal should be over here somewhere on top of the other equal sign. So this is all mixed up. This one's in slope-intercept form. You might be thinking, oh, wait a minute, I could graph this. Yeah, you could, but this one's not ready to graph. So graphing's not a good idea. Elimination method is not a good idea. Substitution is a good idea, right? So let's go with substitution here. In substitution, you pick an equation and you get a letter by itself. As you can see, the top equation already has y by itself. So I just need to take that variable expression that y equals, and I need to plug it into the other equation into the y, right in there. Why am I plugging into the y and not the x? Well, because it says y equals. If it said x equals, then I would be plugging into the x, but it says y equals, so I plug it into the y. Anyhow, when I use substitution especially, I like using arrows. So let me draw some arrows all over this thing. And let me rewrite that bottom equation. That bottom equation says 5x minus y, but instead of y, I'm putting the parentheses, equals 8. Now inside those parentheses, I'm going to plug in the y value that's up here of 3x minus 24. So that's going to go in here, 3x minus 24. And now I could focus in on this single variable equation. Of course, we're going to distribute. Whenever there's distributive property, you do it. And technically, that's like a negative 1. Negative 1 times 3x, that's negative 3x. Negative 1 times negative 24, that's positive 24. And of course, let's bring down the 5x that's in front. Let's also bring down the equal sign and the 8. I have distributed. I still need to do combining like terms. So I have this 5x minus 3x, and we know that that's 2 x's. Bring down the rest. Plus 24 equals 8. My final step, or not final step, but my final 2 steps will be to subtract 24. Subtract 24. I'll have a new equation that reads 2x equals 8 take away 24 is negative 16. So I'm down to my last step here, 2x. I need to get rid of the 2, divide by 2, and we will have our first answer, x equals negative 8. Once you have one answer, you need the other one. Simply plug it into the original, any equation you want. Which one's a good one to do, top or bottom? Top. All right, let's do top. Why is that? Because it says y equals 3 times x. Well, x is negative 8. So y equals negative 24, because 3 times negative 8 is negative 24, minus 24. So I already know that y is going to be negative 48. Let me just show my work here. On the top equation, y equals 3 times x minus 24. We are plugging in the y value of x value of negative 8. So we really have y equals negative 24, because 3 times negative 8 is negative 24, minus 24. So y equals negative 48. So that's your final answer. Final answer is negative 8, comma, negative 48. You see, it's easy. Any questions? Okay, so I've already done numbers 2, number 3. All you guys need to do is the rest. Jumping to number 4. In order to solve this guy, The best method is probably what? Graphing? Elimination method? Elimination, right? So we need to decide. We say elimination because they're lined up. The equals on top of equal, number on top of number. So what do you guys want to cancel out? X's or Y's?
Y. No, X's.
X's? Y's? Let's go with the, I don't know, you tell me. Whatever you say. X, okay. He says X, I'm going with X. So if I want to cancel out the X's, I need this 11, this negative 11, I need it to become a negative 55, and I need this to become a positive 55. So multiply the top equation by 5 and multiply the bottom equation by 11. That way you get a negative 55x on top and a positive 55x on the bottom. So let me show my work here. 5 times negative 11, that's negative 55x, and then 5 times negative 10y, that's negative 50y, equals 5 times 17, which is 5 times 10, 50, 5 times 7 is 35, 85. I did distributive property in my mind. Of course, you could use calculators. Now, on the bottom, we're going to have 11 times 5x, which is 55x. 11 times negative 7, negative 77y, and 11 times 50, 550. Yeah, ugly numbers. Nevertheless, you can use calculators. You should use calculators. I have a calculator right here. So the 55x and the negative 55x, those eliminate. And when I combine 50 and 77, negative 50 and negative 77, I should get negative 127 of those y's. And it equals 550 plus 85, which is 635. 635. So even though those are ugly numbers, we still have a one-step equation in red right there. All you need to do is divide by negative 127. And if you take the 635 and divide by negative 127, you will get negative 5 as an answer. Now, of course, I did this with my calculator right here. I don't know what 635 divided by 127 is off the top of my head. So you could use calculators, and you will get the answer y equals negative 5. So if you have one answer and you need the other answer, all you have to do is plug it back in to any equation you want. Which one should I do, top or bottom? Bottom looks a little easier. Let's go for it. The bottom equation reads 5x minus 7y equals 50. Notice the y, I put parentheses because I'm going to plug in the y value of negative 5 right in there. So let me rewrite my new equation. It says 5x. Negative 7 times negative 5 is positive 35, and it does equal 50. So all I need to do now is solve. I'm going to subtract 35 on both sides. I'm going to get 5x equals 15. Final step would be to divide both sides by 5. I will get x equals 3. So our answer to this question, number 4, is going to be the coordinate, the coordinate 3, comma, negative 5. Jumping to number 5. Okay, so let's all jump to number 5. We want to solve this system. You could do substitution if you wanted to. You could graph if you wanted to, but the easiest method is obviously elimination method, right? So why elimination method? Because they're lined up. Not only that, this y and that y, it's already ready. All you got to do is combine the lines. So let me just put a line down here, and let me combine 4x and 5x. That gives me 9x. This positive y and this negative y, they eliminate. The equal sign comes down, and the 24 plus 12, that is 36. Ladies and gentlemen, we have a simple one-step blue equation right there. So what do I do from there? Divide, that's right. Divide by 9. Divide by 9. My answer is x equals 4. Easy peasy. Now we have the x, all we need is the y. What do I do? Plug it in. Which equation would you like to plug it into? Top one? Okay. So let's rewrite the top one. The top one says 4x plus y equals 24. Let me rewrite it. 4x, obviously I put parentheses there so I could plug in the x value of 4, plus y equals 24. So 4 times 4, it really is 16 plus y equals 24. I need to get rid of that 16. What do I do? Subtract 16. Subtract 16. I will get y equals, I believe that's 8. Yay? Yay. Okay. So we have the answer 4, 8. The answers are on the back of the page, but then again, you guys could simply plug in 4 for x, 8 for y, and it should give you a true statement. If you plug in 4 for x here, 8 for y here, it should give you 24. If you plug in the x's and the y's, it should give you 12. So that's how you double check. Let's move on to number 6. So should I do elimination right here? Substitution's probably better. I am not doing elimination. Yeah, x's are on top of x's, but notice this equal sign is not on top of this equal sign. This y is not on top of this y. It's all mixed up down here. So you could rearrange it for elimination method, but I would just substitute because you already have the bottom equation saying x equals this junk right here. So if it does have a variable by itself, it's ready for substitution. All you have to do is take the variable expression, plug it into the other equation into the x. Now, why am I plugging into x? Because it says x equals. If it would say y equals, then I would plug it into y. But it says x equals, so I plug it into x. So what I'm going to do now is first make some more space here. I'm going to rewrite my equation this way. And instead of 6 times x, I'm going to write 6 times parenthesis, and then minus y equals negative 145. And inside those parentheses, I'm going to plug in the x value of 4 minus 2y. 4 minus 2y. So now we could focus in on that new equation that only has y's, no more x's, and we could distribute, combine like terms, and then solve. 6 times 4 is 24. 6 times negative 2y is negative 12y. Bring down the minus y, bring down the equal sign, bring down the minus 145. Now right here we have 3 terms. I'm going to combine the negative 12y and the negative y. If you owe $12 and you owe another $1, it's going to be owing 13. So my new equation is 24 minus 13 of those y's, and it should still equal the minus 145. I need to continue solving. What do? Subtract 24, subtract 24. My new equation is going to be negative 13y equals, on the safe side, let's use a calculator, minus 145 minus 24, that's negative 169. I just did that on a calculator. Then I'm going to divide by negative 13 on a calculator, and I believe that's 13, the answer. Yes, it is. So y equals negative divided by negative is a positive. 169 divided by 13 on a calculator is 13. So I have one answer. I still need the other. Which one's good to plug it into, the top or the bottom? I'd go for bottom. You could do the top. The bottom says x equals, and that's what we want, 4 minus 2y, but instead of y, I'm putting a 13 right there. So I really have 4 minus 2 times 13, that's 26. So 4 minus 26, the answer is going to be x equals negative 22. Got it right the first time. So, as a coordinate, negative 22, first try, negative 22 comma 13. So, you should practice this entire worksheet. And there's only one more question on this worksheet I want you to try, which is the basketball question, number 9. Number 9 is slightly different than what we did on the class opener today. On the class opener, we had a guy that had nickels and dimes, and he had this much money in there, and we labeled the number of nickels N, labeled the number of dimes D, and we created our system of equations. So what we're going to do right here is first of all read. It says, Anya made 14 baskets during her game. Some of these baskets were 2 points, obviously 2-pointers, and others were 3-pointers. In total, she scored 30 points. Write and solve a system of equations to find how many 2-point baskets she made. Now, like normally on the class opener, I said, this guy has this many nickels, so we put N for nickels. And then this guy had this many dimes, we put D for dimes. But the thing is right here, a 2-pointer starts with the T, 3-pointer starts with the T. So it's kind of confusing, right? So let's just go back to what we've always used, X and Y. But before just starting with X and Y, let's actually do some notes here. Let's put X is going to represent, let's call it the 2-pointers. Actually, we should say X is the number of 2-pointers, right? And we're going to say Y is the number of 3-pointers. Okay? So now that we know a variable that represents 2-pointers and a variable that represents 3-pointers, now we could actually create an equation. And let's read again what it says. The first thing it says is that she made 14 baskets in her game. So what kind of equation could we write? Now we don't exactly know how many 2-pointers or how many 3-pointers.
You could do X plus Y equals 30.
X plus Y. Okay, now remember, X is the number of 2-pointers. Y is the number of 3-pointers. 14 baskets, right? So what we're saying is we don't know how many 2-pointers, we don't know how many 3-pointers, but we do know that if we add up those baskets of 2-pointers and 3-pointers, we have a total of 14 baskets. Because that's what it starts with, that she makes 14 baskets.
Would you do
And now the other equation, we want to be specific about points.
so it'd be 2X.
Yes. How much is each X? It's 2 points. So we're going to say 2X. Well, I'm sorry. 2X, because for each X you get 2 points. For each Y you get how many points? 3. So plus 3Y equals, and how many actual points did she score? 30. 30 points, right? So now we actually have a system of equation that we could solve. Now this is a little different than the class opener today. On the class opener, I had nickels and dimes, and we said, okay, this many nickels plus this many dimes was this many coins. And then the second equation was based on money. Each nickel is worth 5 cents. Each dime is worth 10 cents. But right here we're talking about 2-pointers and 3-pointers. So it's the same concept, but instead of making an equation on money, we're making an equation on total points, since this is a basketball game that we were talking about here and the points that she made. So anyways, now that we created the system, that's actually the hardest part. After that, you just need to you need to get it ready for elimination. So what would I have to do, Bernardo, to get something to eliminate right there? Multiply the one above by -3. That's if you want to cancel out the y's. Yeah, you need a -3 right here. But why not cancel out x's? To cancel out x's, what would you need to have right here? A -2x, right? So it's easier to multiply, I mean, at least for me, it's easier to multiply by -2 than by -3. Keeps the numbers a little smaller. So I'm actually going to multiply by -2. I'm going to distribute. So -2 times x, that's -2x. -2 times y, that's -2y. And -2 times 14, that is -28. So equals -28. Now the bottom equation, I'm just going to leave it the same. I'm going to rewrite it. 2x plus 3y equals 30. And now it's ready to combine. So the x's eliminate, and the y is -2y plus 3y. What do we get? 1y. Right, Eddie? Yeah. So you have 1y equals -28 plus 30. 2. So it's just 1y equals 2. You don't even need the 1, right? It's just y equals 2. Let me erase that, the 1. So y equals 2, that is one answer. The other answer, we're just going to plug it back into any equation we want. Probably the top one, it looks easier. So the top one reads x plus y, I'm going to put a plus 2 in there, equals 14. So what number plus 2 equals 14? 12. So the answer is 12. Show your work. Subtract 2 on both sides. X equals 12. So your answer is 12, comma 2. Now, you know what? Since we're not really talking about x values and y values, since we're not talking about a location on an xy plane, since we are talking about an actual real-life situation, it's better to represent our answers in terms of that real-life situation. So we said that the x's represented 2-pointers. So the answer is she scored 12 2-pointers. And she also did 2 3-pointers. And that's your answer right there. She did 12 2-pointers and 2 3-pointers. Yay? Excellent.